Hello Internet, Daily Codes here. As you program, most of the time you will find yourself in a situation where you want to write a function that has a very simple logic, and you may use it only once or for a very short period of time. If this is the situation you find yourself in, then you need to write the function anonymously. So today I'm going to take you through how to write anonymous functions and how to leverage the power of anonymous functions in data science. I will also throw in map and filter functions, so hit that subscribe button and let's learn something. Anonymous functions are functions that are defined without a name. While we define the normal functions with the def keyword, anonymous functions are defined with the lambda keyword. That's why they are sometimes called lambda functions. They are discardable functions that can be used only once or for a very short period of time, and they mostly contain very simple logic. The syntax of anonymous functions is lambda, then arguments, colon, then expression. You can pass as many arguments as you want in a lambda function, but there can only be one expression in the lambda function. Here is what I mean. Assuming you have these three functions, the first function helps you to multiply a number by 10. Let me make this bigger. Okay, so the first function helps you multiply a number by 10. The second function adds two numbers, and then the third function gets a maximum of two values. These three functions can be written as anonymous functions because they only have one expression. So to write an anonymous function for this, I could define the multiply function as lambda x, then we return x times 10, and I'm going to call this multiply 10. So we could call multiply 10 with a specific number like 2, and it gives you 20. So this function that we have used here is an anonymous function. The same can be done for adding 2 instead of, so the same can be done for adding 2. We could say add 2 equals 2, so the two the lambda, then the two arguments, then the colon, then we return x plus y. So when we call add 2, then we say 2 plus 3 should give us 5. Then get max could also be written as a lambda function, lambda, then pass two arguments, and then we are going to return x if x is greater than y, else we return y. So when we do get max, then you say 30 and 40, get max gives us 40. So these three are definitions of anonymous functions. Lambda functions are mostly used together with higher order functions, and higher order functions are functions that take other functions as arguments. Examples of higher order functions that are best friends with the lambda functions are map and filter functions. A map function takes two arguments. It takes in a function and an iterable. The iterable can be a list, can be a tuple. can be any object in Python that you can iterate through. What map function does is it iterates through the iterable, picking element by element, then passes the element to the function that is passed through the map function. Then the result of the function with that element passed through is appended into a new iterable. And then when it completes iterating through the iterable, the map function returns an object of the map function. Here's what I mean. Let's say we have a list of items. So this is our iterable. It could be a tuple, but let's use a list. Then we could call the map function, and what we want to do is to get the length of each item here. So the map, the first argument to the map is a function. So what I told you is that here it takes in a function, and then there is an iterable here. So the function here that we're going to define will be a lambda function, and it takes in a value item. So it's going to take an individual item from this list, and what are we going to do with that item? We're going to return the length of the item. So the length of the item will be the number of characters in that item, and then the iterable here is our list one. So when you run this, it is returning the map object. But for us to access the list inside here, we can call this list, and voila. So apple, or apple, depending on where you're from, has 5 characters, banana has 6 characters, and cherry has 6 characters. So you can see how we use the lambda function with the higher order function map to get the values of the function through. So it is more of applying the function on each of the item in the iterable. The filter function is also a higher order function that takes 2 arguments, a function and an iterable. The function passed through the filter function is a function that returns Boolean values, either true or false. The filter function iterates through each element of the iterable, picks the element and passes it as an argument to the function that you have supplied to the filter function, and then the function that you have supplied to the filter function will either evaluate into true or false. When the function evaluates to true, the value that is passed to that function is kept in the iterable. But when the function evaluates into false, the value is not kept. So the iterable that is returned will be a iterable object that contains only values that evaluated into true and not false. So it is like filtering out the original iterable into the subset of the iterable. This is what I'm meaning. So I have a function here, check, that gets a parameter, a letter, a value, and it checks if that value exists in this list. So what basically this does, it returns true if the value you've passed here is a vowel, and returns false if the value is not a vowel. So we can use this in filter. We filter these letters to get only vowels. So we can say our filter, the function here is check, and the iterable is letters. Let's pass this to filtered objects. When you run that, we could get the values from here, the list of filtered objects is that So this is how filter works. So we have seen how to use lambda functions and how to use lambda functions with higher order function. I haven't shown you how you can use it with filter, but I've shown you how you can use it with map, but it is kind of the same way. So now what we're going to do is to try to use what we have learned with the real world data set and see how far we can go. So the data that I have is lyrics of songs from Drake. I think they are unreleased songs, but I found them from Kaggle. You can always visit Kaggle if you want pet projects. There is lots of data there that you could work with. So I'm going to work with this this data set and see what we can do with the lambda functions. Yeah. So the data is in a JSON file. I'm going to import JSON. And then let me import the whole data set. So I'm using JSON package to import the data and manipulate the data. So I'm importing it as a list of objects or list of dictionaries with 290 records. And if we want to look at the first two, you're seeing this first one. Where does it end? It ends here. So it has the album, lyrics title, lyrics URL. The lyrics is not too long, so this may not be important in any analysis. But these are the number of views. Then this is the second one. So this is the data that we're going to be working with. The next thing I want to do now is to try to find the length of each lyrics and in each song. So I'm going to do, this is list comprehension. So the length of the song, song being the lyrics, the song anyway, the object, lyrics, for song in Drake lyrics. So this will return to me the length of each lyrics for all the songs, all the 290. Let me run this. So I have an error here. It's saying that the object of type none has no length. So there is a lyric somewhere that is of none type. It is none. So here we're going to use a filter to remove it. So I'm going to say let me first do something here. So I'm going to use a filter here. I'm going to say Drake lyrics is going to be still a list comprehension. Let me just do a filter. So filter, and then the function should be lambda song, and we say song lyrics, it should not equal to none, because this is the none type. Then the iterable here is the Drake lyrics. But remember, this function here is going to return the filter object, so let's let it return the list. So this will be the filtered list without the song that has a lyrics that is none. So when I run this, it's fine. Then when I run this, it runs. So we have removed the lyrics. Remember at first it was 290, so we could check the length of this now and see how many songs we have removed. 299, so it was just one. Okay, so yep, this is fine. So what else could we do? We are seeing that each object here has a title, has lyrics, and has views. We could try to find out if the title, the number of characters in the title, and maybe the number of words in the lyrics correlates to the number of views. So how to do this? We're going to use a map function. So I'm going to do map, and I'm going to use a lambda function here, lambda, and for each song I want to return a list, and this list should be views. So these views are in, they're coded, so this is in thousands, those in millions. So I need to write a function called get views. I'm going to write it later. So get views to just give me the views. So song, then this track views. I need views as either integer or float, but it should be in numerical views, not a text. Then I need the length of the lyrics title, the song title, I mean song, then the title, what was the name of the title, lyrics title, yeah, then the length of song, and what I need to pick here is the lyrics. This is the lyrics, but I need the length of the number of words, so I'm going to split it by space. So this will give me words, I hope so. There is /n, that means we need to clean it a bit. What I'm going to do here is for song in direct lyrics, I want to clean it so I can remove these /n's. Direct lyrics, I'm going to do song lyrics should be equal to the same song lyrics and song lyrics, the same song lyrics dot replace the new with space. This will work, I think. Okay, here that will work. When we try to check this again, you're going to see that the /n's have gone. There is so many ways you could clean this up. You could continue cleaning it to get perfect results, but for us we want to see how much we could use lambda function in this problem. So I have not defined get views, so I'm going to define get views. So I've defined get views. It takes in the track views. For example, it could take this value here. If that value is none, we return 0.0. If we have k in that string, then we replace k with nothing, we convert the string into float, then we multiply by 1000. The same thing as m. If m is in that string, we replace m with nothing, then we convert it into a float, then we multiply it by 1 million, else we return 0. Yep, so I think this is ready. Let's see what we're going to get here. Error. Map must have 2 arguments. Yep. So map, we need to pass in here the track view, not the track view, sorry, direct lyrics. Not the error. Get views is not defined. Run this, run that, and yeah, so this is the output. And now we are going to try to find their correlations. So I'm going to call this L4, and then I want to convert this L4 into an array. But before I convert it into an array, I don't want any value in L4 that is equal to 0. So I have a feeling that for any length of the title that is 0 or length of the song that is 0, it may skew our results, so I'm going to remove it. So I'm going to use a filter. This is just me finding an excuse of using a filter function. Lambda, song statistics, song stat. Then I'm going to, the function should be, I don't want any value in any of this. So remember that this is an L4. So I'm going to let me first show you what L4 is. So L4, let's just get the first 2 values of L4. So it is a list of lists. So I want any number here being 0. If you have this list here with any of the number being 0, we drop that list, we don't include it. So we filter it out. And what we are going to do, I'm not so sure, but I think I'm going to use a map function here. Since song start is like one of the statistic for a particular song, so I'm going to say lambda start. So start is a particular value, this single value, and the function should be a truth function. So start being equal to 0. Then what we are passing here is song start. So what's happening here is song start is a list, is an iterable. So that means we can iterate in it, and we are going to iterate in it, and we check, we return true or false if any of the values in them is 0. So it will return a list of false, false, false. If this was 0, true, false, true. Then from there we can use any. Yes, any. So any is a function that that returns true if true exists in the list. So this should be a list, not an object. Sorry, there is too much encapsulation. But so map will give you the object, list gives you the list of the truth values, then any will return true if true exists inside there. But we want what do we want? We want to filter out songs that have 0. So if it returns true, that means it has 0 and it should be false. So we're going to put a note here. And yeah, so this, I'm going to return the list from it. This is not the best way of programming, but filter needs 2 arguments and it needs this. Yep. So these are songs which at least have a title and have lyrics. Then I'm going to make it an array. So I'm going to import numpy. Import numpy as np. So np dot array np.array would have not used direct lyrics. We need to use L4. NumPy is not defined, and voila, we have our NumPy array. I'm going to call this data. So we know data, in this data, the first column has views, the second column is the length of the number of characters in the title, and then the third column is the lyrics. So we could use we want to do correlation, so we could do from scipy dot stats import Pearson. Want to do Pearson correlation, Pearson R. Does it exist? Yeah, it does. So my correlation and the other correlation anyway is going to be Pearson R, and then so I want the correlation of data, the views with the title, the length of the title. The title is here. What is the correlation? Not so correlated. Then I could try the correlation of still the views but with the number of words in the song. And also it's not so well correlated. There may be different ways of looking at the relationship between the views and the title and the number of words in the lyrics of direct songs. But so far you've seen how we can use anonymous function, higher order function of map, filter, and yeah. So we saw lambda functions. We have seen how to use them in higher order functions. We have seen how to use them in data science, and we have conquered them. If you have not subscribed to the channel, please subscribe to be notified every time I upload. Till next time, take care of yourself.